Hello everybody. Here we are going to learn how to draw a blade for wind turbine. The blade drawing is shown here. I'm going to use this drawing, but basically the airfoil section is going to be different. As we can see, we have two parts. One, the main part of the blade, the other part is kind of the connector to the hub. In order to do that, we need a few cross section. Airfoil had a few cross section. Here I'm going to use NACA 0012. We may have 10 cross sections, or one cross section here, one here, one here, here, up to the tip. For the sake of demonstration, I'm going to use only 3 cross sections, one at the root, one in the middle, and one at the tip. And all of the cross sections are going to be NACA 0012. They could be different. The chord size is given. Here is 20 millimeter, at the root is 55 millimeter. Here I'm going to apply something like 0.027 meter or 27 millimeter in the middle. So basically I need 3 planes, one plane here, one plane here, one plane here. Draw each airfoil, one airfoil here, one airfoil here, one airfoil here, and use loft to basically connect all of them together. One point here is to make sure the aerodynamic center of all of these blades all coincide, on top of each other. For example, if aerodynamic center of this airfoil is here, the other one should be here, and this one should be here. They should be in the same vertical line in this drawing. So let's start drawing. I can open SolidWorks. Before using SolidWorks, we need shape of the airfoils, basically X, Y, and Z of airfoils for NACA 0012. For that, I'm going to use a website called Airfoil Tools. I have it here. And if I want, I know the airfoil type is NACA 4-digit. I click on that and I can write the name NACA 0012, search for it. Then I can see a few items here. This item, if I click on that, I can see the coordinates. It's only X and Y. There is no Z because it's two-dimensional shape. However, for SolidWorks, we need 3, X and Y and Z. So we will manage that. Let's first save it. Save as txt file. So let's call it NACA 0012. And by default, it is 1 meter. The chord size is 1 meter. Let's write 1 or 1 meter. Save it. I can see it here. If I click here, I can go there and see the data. I can delete this part. In order to add Z as well, basically SolidWorks can only read X and Y and Z data points. And also change the chord size, I'm going to use Excel. So if I first copy, then I will create Excel file. Let's call it NACA 0012. I can copy and paste them here. Let's Control V. Then as it is clear, all of them are inserted in one column. I need to separate them in different columns. To do that, you can use basically data here and then text to columns. Here, so here we can see they are separated in different columns. Finish. Now they are in separate columns. Okay, so we can apply Z here by simply write 0 and then drag and drop it till here. Okay, now we have created Z. And in order to change the length, the chord size, we can use a simple formula. Equal sign, then this one time the size. For example, let's say first I want to go for root 55 millimeter. Then I can bring it, extend it to here, this formula, then extend it to all columns and rows, basically what I'm doing. Now this is the coordinates of NACA 0012 with this chord size. I can copy and paste to a text file here. Let's create a text file. Oops. Text file, call it NACA 0012, then 55 millimeter. Copy and paste it here. I can do the same for the other sizes. For example, the other one was at the tip was 20. Let's get back to drawing here to let you know. So here is the chord size is 20 millimeter. Here it was 55. So I created 55. Now I'm going to create this chord size. So 20. Then I can again extend it to all columns and rows. Okay. Then copy, go there, create a new text file, call it NACA 0012, then 20 millimeter. Then copy and paste. And as I said, in the middle, I'm going to have another airfoil. Perhaps you might have 10 airfoils, so you should have 10 chord size, and perhaps the airfoil even are different. So you have to download different airfoil from the website and change their chord size accordingly. I'm going to have another, for the sake of demonstration, I'm going to have another airfoil here in the middle. So the all length is 107 millimeter. I'm going to have another airfoil here with a chord size 27 millimeter. So let's go there and change the chord size to 27. Okay. Then extend it to all columns and rows. Then copy and paste it here. Let's call it NACA 0012, 27 millimeter for the chord size. That's it. So we are done with the airfoil coordinates. Now let's go to SolidWorks, select part. In order to apply basically 3 cross section here, one root, one is middle, one is here. As I said, you might have 10 or 20 depending on how accurate you want to have cross sections. So I'm going to go for 3. In order to do that, let's first get out of this sketch mode. So here we need to create 3 planes in order to draw each airfoil on that plane, on one plane, and then use loft to connect them together. So I'm going to use front page and then insert reference geometry plane. Then the distance between the plane should be this divided by 2 because there is one here, and one here. So the distance between them would be 107 millimeter divided by 2. Okay, so that would be something like 535 and then 3. Okay, that's it. Then I can import the airfoils. So let's start with the root airfoil. Click on curve. You might see it here, you might see it here, depending on the version. And curve through X, Y, Z points. Then browse, text file. The first one is going to be at the root. So this one I'm going to import. Okay, that's it. If I zoom in, I can see it's not closed at the end. That's fine. I will close it when I project that to the plane. So first I want to project this one to this plane. And here I'm going to have the root. So in order to do that, I right click sketch and then use convert entity, then select this one and apply. So I can see here I projected this curve. I can hide it now. As I said, here it's not closed. In order to close it, I can use the best way. You can use a line, simple line, but I wouldn't recommend that because when you loft it in 3D geometry, you would have one surface here, one surface here, which is a tiny surface. I would recommend using tangent arc and then connect this both together to make sure it's connected properly. Okay, that's it. So when it's tangential to this, connected in that way, we can make sure that when we create a 3D shape, all of that would be one surface. Okay, that's it. Now I have the first airfoil, something important, because when I have 3 airfoils or 10 airfoils at different cross section, I need to make sure the aerodynamic center are on top of each other. So in order to find out the aerodynamic center, I know it is 1/4 of the chord far away from the leading edge or 75% of the chord far away from the trailing edge. Let's draw a line from trailing edge. Draw a line here, horizontal line. And let's make the size 75%. So 75%, how much would be the size? Let's use calculator. 7. So the size is something like 55. That's the size of the chord, and 75% of that would be this number. Okay. If I can copy it, I can use this size. So here is the aerodynamic center. Okay, that's fine. Now we are done with this. That was the first airfoil. Okay, we can hide it to go for the other ones, or perhaps we can keep it. So let's bring the curve here in the middle. Again, curve through XYZ points, browse. So the one with 27 millimeter. And then apply. And then project here to this plane. So this plane, and then edit, and then go to convert entities. Convert this entity, then apply. Okay, that's it. Now let's close this by this tangent arc. Now draw the line, make it horizontal, so that's horizontal. Then we can set the size. The size was something like this. Okay, now it's black and I can make sure it's fully defined. Okay, let's go to the last airfoil. So we can hide this one. Before going to the last airfoil, I want to show how to put, all the center together. Make sure that the center of aerodynamic are basically on top of each other. To do that, let's take a look at this perspective so we can see they are not on top of each other. In order to do that, I want to move this one. So keep this one fixed, move this one. In order to move this one, double click, make sure that this, because here we define that it should be on the edge. I can remove this to allow airfoil moving, and now I can see airfoil can move. If I click on that, I can see it can move or something. Now let's just Control Z. So let's make sure it can move. You see it can move. Okay, so now I can select this point, hold Control and select this point and say coincident. Okay, now it moves. And if I look at the normal perspective, I can see they are on top of each other. Okay, so that's how I can make sure the aerodynamic center on top of each other. That's fine. So let's go to the last one. I can import the first coordinate as a curve, text file, then NACA, the one at the tip, and then project that to this. So let's edit the sketch here and then project this one to this. So I can select convert entities, then select this one, then apply. So I convert it. And now I can safely hide this. As I said again, I need to close this. I use tangent arc. I zoom to make sure the points are connected well. Then I need to draw the line to find the aerodynamic center. Let's draw the line. That's not the only way. There are different ways of doing that, but I use drawing a line. So I can make sure this is horizontal. Click. That horizontal sign is there. Then I can use smart dimension. So now it becomes so to find how much far away I should go. Let's go to calculator. It is 0.02 times 75% becomes 0.015. So I can use that. 15. And it's all black. That's what I want. In order to make this movable, I need to double click here and remove on edge. Now it's movable. Now in order to make sure the aerodynamic center is the same here, I can click on this. Oops, let's first escape, then hold Control, click on this, and then click on this and say they are, so it moves. Great. So now I can close sketch editing. Let's take a look at them. So the aerodynamic center is on top of each other. Then I can use loft to create the blade. Loft pass space. Okay. So I can select this. Okay. Then select this. Okay. Then select this. Okay. Great. Now I have created the blade that I want. Let's just hide them. Now this is the shape of the blade. And as you can see, as I said, here these edges are connected all together. This is one all surface. This is not a separate surface and this is not a separate because I use arc and they are tangential. So that was the best way. If you had a line here, there was a separate surface here, and for CFD modeling, for example, then you need to create mesh for that because it's very tiny. The mesh should be tiny and you have lots of non-orthogonal cells because of only that. And in that way, I just created one surface on top and one all connected to here. Great. So now let's create the other part, which is the connector. Okay. For the connector, I can use this one. Let's take a look at here. This one. So I first draw the outer part. That's a circle with a size of 4.40. That's millimeter. So I can start from here. Click on normal perspective, and I can draw a circle here. Let's put it somewhere horizontal here, for example. The size should be 8 because R was given, so I need to apply D here. It was 88. Oops, no, that was wrong. I guess it should be 8 millimeter, 8.8 millimeter. That's correct. And the center of that, how much it should be far away from the trailing edge or leading edge. Let's get back to the drawing. Here, 34.5. So how to do that? I can use this smart sizing and say the center of this, how much far away from this. Okay, because I cannot see any points here, I can create some points here first because it's not selectable. What I can do, I can convert this entity. So let's convert this entity to bring this entity into the current plane that I'm working on. If I click on the entity, I can bring it out. So now you can see the black line. Now it's selectable. I can find the distance. I click on this and click on, for example, one of these points. Okay, now it's selectable. 34.5. Okay, now you can see this circle is fully black. I mean the black, it means that fully defined, which is great, what I want. Then the second thing I have to do is to define this, basically draw this part in B section. I have shown B section here. B section is here. I know the size is 3 millimeter. The width is 1.86. So I can draw it here. Let's draw it just by chance, like something like this. Then I will define them. Let's first say the middle of this line. The middle of this line, find the middle is here, midpoint. Click. Oops, let's first escape to make sure I'm not drawing another one. So find the middle of that line is here. Hold Control, select it, then select this one, then the select midline, midpoint here. I have 3 points, and I can say they are horizontal. So they move to be horizontal. So the center of these are horizontally aligned. Then I can define this as 3 millimeter. So this as 3 millimeter. This one as 186, I guess, or 7. 186. The same here. 186. Okay. Now I can trim away. Select trim, and then select this last one. Then you can safely, for example, this one is not needed, this one is not needed, this one is not needed, this one is. So it's all one face. Now, if I look at here, this should come out basically 17.5 millimeter and go in. This should go in by 2.5 millimeter. So that's how it's defined here. What I will do, I will just use this extruded. I can select this one, and the bottom one perhaps. That is an option here. Oops. Okay, in that way, perhaps that's one way. Great. I can here define the size coming out, then direction 2, size going in. Okay, so now I have created this part. Then I need to create a hole on top of that. So here there should be a hole. If I go to drawing, I can see a hole. The distance between this and the center of the hole is 7.2, and it should be in the center of this. There are different ways of doing that. So first I need to define a plane, so I can do it on top plane as well. So top plane, look from normal perspective. I can start drawing a circle. Let's draw the circle here. The distance, let's take another look. The distance is 7.2 and the size, the diameter is 3.1. So use this smart dimensioning, 3.1. Then the distance between this and this edge is 7.2 millimeter. Okay, then I need to make sure this is in the center. There are different ways of doing that. So if you select this, and then if I can select another point here and I can say they are horizontally connected, so it's not selectable anything, I can convert them and bring them on the current place. For example, I can convert that to the current place. So let's see if this is not selectable, I think. So to convert that, I can use convert this entity and then bring it here. So now it's to the top plane. So now I can select the center point. I can say the center point on that, hold control and select the center point of that or midpoint. Then I can say vertically align. Okay, now this moves to make sure this is vertically aligned. Okay. Yep. And now I can end a sketch. Then I can cut it through. So select cut, select this sketch, and I can select through all. Okay, it worked, but okay, it's not work as I want, so it should be cut through. If I click edit feature, through all, both sided, through all. Now it's what I wanted. Okay. The other parts are this part. So there is some cutting here and there is some chamber here. that cutting size are given here. For example, from which figure I can see that the cutting side from this figure. If I look at here, E, I can see section is here, and this one is almost 2 mm backward, and then chamber here, and then another chamber here. Okay, so 2 mm, 2.1. I can come here, draw the define the sizes. 201, and then close it. Okay, that's it. And I can cut it through. Draw. Okay. Then I can use chamber to the chamber was given 1187, and I want to do the same here. So I can select this and then draw this rectangular shape to be used as cutting sketch. Then sizes. Okay. And then cut through. Okay, and then the chamber here. I can select this edge, then again that one is defined, and okay. And the last thing, another chamber with 1 mm. Okay, that's it. Now I have created the blade as I wanted, and if I compare that with this drawing, here is here. And now that is the blade that I have created. I can generate drawing out of that and compare with the one I just saw. But this is the blade, and we can use it for CFD modeling. We can use it for 3D printing. We can save it here. Blade NACA 0012. In case I want adding some twist to that, I could add that. So let's just try that for the sake of demonstration here. If I get back to loft and I just want to rotate these two, for example, let's say this one. If I want to rotate that, I can select it. Then I can go here, tools, sketch tools, then rotate. Then I can select all of the items I want to rotate. Let's select everything to make sure everything is going to be. Then the point of rotation, then the size of the rotation. So let's say, for example, 5. It should be positive or negative. I mean, depending on the aerodynamics that we want. So let's say 5 degree. I rotate it in this way. And now, so it's a bit rotated, but let's rotate it more to see it. But I believe it's rotated. I should have used a bigger size. Let's get back there. Again, tools, sketch tools, Then rotate. Select all of the items here in this sketch. Then select point of rotation. Then let's save 10 degree to be totally 15. Now if I get back, I can see it's rotated. Okay. I could have rotated the other one here to make it smooth rotation. Then select tools, sketch tools, rotate, then select this one, and this one. And point of rotation is around the aerodynamic center. That's very important to be here. Okay. Then let's say this one, for example, 7 degree. Now I can see a twisted blade. Okay. That's a twisted blade. Let's save it as a twisted. Should I twist it that upward or downward? It has to do with aerodynamic behavior that I want, but that's how you can apply that. Either upward or downward. You could have changed that by negative or positive. That's the end of this